Welcome to qnawire.
In this problem, we have a particle that is moving under a central force, and hence its angular momentum per unit mass, h, is equal to a constant. And h is defined as r squared theta dot, d theta dt. And since this is a constant, we can write this as h naught. And this is simply r naught times v naught, the initial position times the initial velocity. So rearranging this, we can find an expression for theta dot. So theta dot is simply r naught v naught over r squared. And this becomes r naught v naught, and we'll open out the expression for r. This becomes r naught squared cos squared theta. And so we see one r naught cancels from the top and the bottom, and this becomes v naught over r naught cos squared theta. So the first thing we will do in this problem is find the radial component of the velocity. So the reason we needed to find an expression for theta dot is to find the components of our velocity. So the radial component Vr is just r dot dr dt. And so that's d by dt of r naught cos theta. And by the chain rule, this is simply minus r naught sine theta theta dot. So r naught minus r naught sine theta d theta dt. And the transverse component of velocity is v theta. So v theta is equal to r theta dot. And r theta dot is r naught cosine of theta times theta dot, just the expression of r times theta dot. So to find the final speed of the particle, v, the magnitude of this speed is simply vr squared, the square root of vr squared plus v theta squared. And so we simply substitute our two expressions into this equation, and we get this to be r naught theta dot. And since we have an expression for theta dot, which we found at the very beginning, this becomes r naught v naught over r naught cos squared theta. And so the r naughts cancel, and this becomes v naught over cos squared v naught over cos squared theta, and that's the answer we require.